All right, so chapter 13, we're going to do the homework problem in 9.5, and it's repeated here. Some policy analysts have suggested a carbon tax as an incentive for energy consumers to switch from fossil fuels to renewable biomass fuels. And this is happening. It's real. It's not huge, but it is happening. The idea is based on the argument that there is no net emission of CO2 into the atmosphere. What does that mean? Let me just draw a picture. And if you guys watch any Elon Musk, he has a little deal out there on global warming, climate change, carbon emissions, the future, et cetera. And I'm going to say it, he went out there and he goes, it's just the turd in the punch bowl. You know, he shows says all the crap we put, you know, because, hey, we're partying, we're humans, we're civilization, let's rock, but like, oh, who put the turd in the punch bowl? You know, it's like, oh, that is no Baby Ruth. That is the Baby Ruth bar. No, it is not a Baby Ruth bar. Oh, no. Call out Bill Murray. But here's the basic idea. Pretty simple. So here's old carbon, underground, coal, oil, gas, and let's actually draw a little tree. It's black, and let's just draw a little tree.
Nice tree.
Banana tree. And this guy is new carbon. And what happens is you've got, of course, CO2, and that goes into the new carbon. It didn't get sequestered. Well, then that goes over to biomass. Here's the plant. You burn it, and then it comes back around. That's basically the cycle. So that's what they mean by that, rather than pulling up this old turd and putting it in the punch bowl. Okay. No net emissions in the atmosphere since the same amount is absorbed by growing it, assuming you plant that tree again. Assume that the coal is available for $1 per gigajoule. Okay, let's get this going. So coal equals $1 per gigajoule. Cheap. While biomass can be grown a little bit about $2.50 per gigajoule. Biomass.
Switchgrass.
Switchgrass.
That's what Tim was trying to figure out the other day, for a few weeks ago.
Yeah, switchgrass.
We use it for a couple of different problems.
Yeah, I don't know that much about it. I do know that it grows relatively quickly. It's hardy. You know, think of it as kudzu. Nobody's going to want to eat it. It grows fast. It's an efficient carbon sequestering organism.
To tell you the truth, I don't think it even is digested. It just kind of goes through.
Yeah, fiber. You know, so it's pulling carbon. You know, it has to pull in carbon from the atmosphere. It has to.
Photosynthesis.
Yeah, photosynthesis. But this is 250 per gigajoule. So obviously the switchgrass is more expensive. And it makes sense because you don't just shovel it. You have to combine it, ship it, pack it. The energy density is a little less, so you're shipping.
Three train cars instead of one.
Yeah, I'm trying to think of a good food analogy. I mean, you're shipping Cheerios instead of steak. You know.
Hamburger instead of steak.
Hamburger instead of steak. Yeah. Okay. Assume that the coal has a heating value of 28 megajoules per kilogram. Okay, so this is the price up here. Now let's do the energy. So 28 megajoules per kilogram. Okay, coal. I could be doing this a different way. 28 megajoules per kilogram. And 70% carbon. How large a tax would have to be placed on CO2 tons per minute before plant operators would concerning burning biomass instead of coal? Okay, hint, this is a break-even analysis, it's also good synthesis of knowledge, and proceeds as follows.
Well, it would have to be 150% more than it is now, if you're at $1 and it's $2.50.
Yeah, so somebody, exactly, so somebody tell me, what are the switchgrass properties?
19 megajoules per kilogram at 15.03%.
19 megajoules per kilogram. What's the carbon?
15.03%.
That's it?
That's it. Not very much to a piece of switchgrass.
That's a lot of, yeah, so there's probably a lot of water in there,
I mean,
mostly water.
It is mostly
A lot of water, a lot of water. Okay, switchgrass. Okay, compute the amount of carbon in each unit weight, we can do that. Compute the feedstock cost per unit weight, we can do that. Presuming that the unit cost of biomass per kilogram of carbon is greater, molecular weights of carbon and CO2, I'll take that as a hint. So carbon equals 12, CO2 equals 44. Got that? Remember that? Carbon's 12, CO2, because O2 is oxygen 16, 16 times 2 is 32, 32 plus 12 is 44.
Yeah, I have that.
What are those numbers?
Molecular weights.
Oh,
Molecular weight, so just straight back, periodic table.
It's pound per pound mole. Is that 44?
Yeah, pounds per pound mole. Mhm.
Gotcha.
So there's carbon 12, oxygen 16.
Gotcha.
Yeah. It's basically for every 12 pounds or 12 kilograms or what have you of carbon that goes in, 44 units of oxygen, of CO2 come out. Exactly, exactly. Okay, so I think what we want to do. So really, what are we after? Well, we're after the gigajoules. That's what you're paying for. You're buying the gigajoules. So, so let's do.
I thought what we hang here, and it says basically to convert it into, picking convenient basis for 1 kilogram of each substance. So I converted everything down to kilograms of CO2.
Yeah, let's figure out how much. Let's figure out how much carbon per gigajoule comes out of each one.
Well, I have kilograms of CO2 per gigajoule.
Oh, there you go.
Is what I want.
Kilograms of CO2 per gigajoule. That works. Yeah, that's what we want to get to. That's what we want to get to. So let's do it for coal. If we've got, let's see, so we're going to have energy per unit mass, and then we also have carbon per unit mass. Let's see, so energy per unit mass, carbon per unit mass, so mass per carbon. I mean, that would give us energy per carbon. Or we could go this way, we could say how much mass do we need per unit energy, and then we would go carbon per unit mass would give us carbon per unit energy. I think that's the way we want to go, right? We want to see how much carbon comes out per unit energy. So let's do it for coal first. So I think this, let's not do it this way. Let's do it that way. So mass per energy on coal, had it right here, mass per energy, is 1 kilogram per 28 megajoules.
So what's your energy per mass? Right?
Yeah, I'm going to flip it around though. This is energy per mass, I'm going to do mass per energy. So so for coal, 1 kilogram gives me 28? 28 megajoules. And now for the, this is of coal. And 1 kilogram of coal gives me 7.7, 70%? 0.7 kilograms of carbon. So,
What do you get to, how did you, well, wait a minute here. Why did you turn the percent into kilograms?
let's see, good question.
Because I see the numbers that you're using.
Coal-
Assume the heating value.
Coal is, yeah, heating value of 28 megajoules per kilo, and contains 70% carbon by weight.
So you're just assuming it's kilograms?
Well, 1 kilogram of weight is gonna give you 70% of that in carbon.
I think so. Yeah, I just have, here's my 1 kilogram, and that much of it is carbon, and the rest of it is hydrogen, oxygen, sulfur, whatever, mercury. Yeah. So there's one. The whole thing is 1, and that's 70%. I think this is right.
It looks confusing to me.
Well, I just started off with dimensional, because we were given this. We were given energy per mass. We were given 28 megajoules per kilogram. That's what we were given. Check. And
7% or carbon by weight.
yeah, and this was, we were given how much carbon. As we knew we really don't want to know the mass, we want to know carbon per energy, so we had to cancel these M's, but then we ended up with energy per carbon, but what we really want is carbon per energy, because that's what we're being taxed on.
Right.
So I just flip-flop the math. So let's see if that comes out.
We've got 0.025.
I'll double check you, thanks. 0.7 divided by 28 equals 0.025 kilograms carbon per 1 megajoule. Doesn't seem like much, but let's think of it this way. So if you think back to your USDA, I always like to bring it back here. So your USDA is 10 megajoules. That means you're gonna burn through a half a pound of carbon, a quarter of a kilogram, a half a pound. That's 8 ounces of carbon. I would believe it.
Well, then when you put up how much switchgrass is, it'll put it in perspective.
Yeah, let's do it. Let's do it. Okay, so for switchgrass, let's look at that energy density. 19. So 1 kilogram is 19 megajoules, yeah. This is switchgrass. And we've got 15%, 0.15 kilograms carbon
Are you
per.
going to put the O3 in there or just exclude it because it's so small?
I'm going to exclude it. Yeah. I'm going to exclude it. 1 kilogram of coal.
Switchgrass.
Thank you. Almost awake. equals, so, 0.15 times, hello, or no, divided by, start off with point, what about, 0.15 divided by 19, 0.15 divided by 19. Okay, so let's say 0079, let's just do 2 sig digs, we did 2 sig digs before.
Change it up on me.
2 sig digs!
Normally it's 3, but all right, we'll do it. Compresses 3 sick days.
It's so close, it's so
2
close.
years. All of a sudden he switches it to 2.
I'm in a hurry.
You're fine.
0079. We'll see how different they are at the end. We'll split hairs at the end. 0079 equals 0.0079 kilograms carbon per 1 megajoule. Okay.
So what was the price that we had? $250?
Yeah, so I guess what we want to do is compare, we want to compare CO2 emissions per dollar is what we really want to get it down to. We want to do CO2 emissions per dollar. Okay, so,
Scroll back up to the dollar sign, to your previous screen.
yeah.
Per gigajoule, okay.
Yeah, because we've got money per energy, and now we've got carbon per energy. We've got carbon per energy, and then let's go ahead and get this into CO2. Let's just do that right now. So coal. So 0.025 times 44. Oh gosh, thank you. Almost awake. 0.025 times 16. No, times 44 divided by 16. 06.
Where did the 16 come from? Is that from your pound wolf?
Oh, 12, sorry, sorry. 0.025
Where did the 16
times 44, thank you, divided by, I've got oxygen on the brain, 12 equals, okay, 0.092.
0.092 carbons per
CO2 per megajoule?
CO2, yep. So for coal, we can say, we can write the whole thing out, 0.25.
It's pretty cool.
Kilogram.
Turn carbon into CO2 just by molecular weight.
Pretty cool.
Chemistry is pretty cool.
It's Mendeleev, I think this is Dalton. I think this is 1860 or whatever, these guys are, like, oh my gosh, air has mass. Oh my gosh, we're breathing oxygen. What the heck's going on? Wow.
Fire.
Did you imagine being the guy that figured out molecular weight?
Yeah.
That was you in the 1800s.
I don't know. I think he was probably,
Just sitting there thinking. Just thinking about everything.
This does weigh something. By the way, don't actually make contact with anything you touch. That was like the hardest thing for me to grasp.
what is?
You don't touch anything?
For what?
When you touch something, what you feel is the pressure of the forces separating the two of you.
Yeah.
You don't actually touch
It feels, I know, the electron thing is a little weird that, no, I'm not touching it, just my electrons are interacting with it, right?
Yeah.
Perception, man. It's all perception.
It's so cool.
So here's 1 kilogram of carbon no, let's do it this way. 12 kilograms of carbon is 44 kilograms of CO2. Gives us that.
Yeah.
And all it is, I mean, just, it's fun to draw the picture too, because here you've got your, yeah, I mean, here you've got your O2, it's floating around in the atmosphere, minding its own business. And, you know, your carbons are sitting down here, and whoop-de-doo, here I come, bounce off, and now I am CO2, which is also a molecule that looks like that. So it is, you know, this, which has an atomic weight of 12, 6 protons, 6 neutrons.
So to get it to do that, you would have to apply heat, obviously. Once it combusts, then it can bond with the oxygen because of...
That's it. That's it. Gives free energy, yeah.
Friction.
The sun puts all the energy into it so it can grow, and we put all the energy into it to burn it and give it back.
Yeah,
Or
That's so
butane
cool.
or whatever.
There it
decides
is.
to Burn it.
there it is.
Such a wonderful process.
It sure is. So there it is, one little tiny carbon cycle.
Seems so simple.
Yeah, it is.
It really is, it just has a lot of numbers involved.
Switchgrass will do the same thing, so 0.0079 kilograms of carbon for 1 megajoule of energy. Same thing, 12 kilograms of carbon, 44 kilograms.
Maybe 16 though? No, it's still 12.
Yeah, I made the same mistake.
So are we having to decide how much tax would have to be implied on the goal for it to be switchgrass all day?
That's exactly what we're doing. 0.0079
0.029.
times 44 divided by 12 equals 0.29er. 0.29. 9.2 versus 2.9, that's kind of funny. If you're into numerology.
Hey, if you're really into algorithms, I'll tell you what. Ever watch that show Numbers? It's kind of spooky.
Is that really right?
Not the only one.
Is this correct though?
I did mine a completely different way than you did.
Did you get similar answers?
I went a different route. I had BTUs per carbon, BTUs per pound, pounds of carbon, pounds per pound mole of carbon, moles of carbon of CO2,
Yeah.
and got it all the way down to gigajoules of CO2.
Okay. I'll take a peek at yours in a second. It's just,
Kilograms per carbon is like 10 times less, so I don't know, that's a tough one, that how you got.
Kilograms of CO2 per
For
gigajoule.
the switchgrass, it's like 10 times less, and you still got the same
well,
CO2 out of that. It would make more sense if it was 0.0029 or something.
well, let's look at it. So with coal, there's, with switchgrass has a lot less energy per kilogram. We'll just give, you know, one third less. There's 30 and that's 20.
Yeah.
So one third less.
Yeah, because in the end, coal had way more gigajoules of CO2 than switchgrass.
But it's getting the energy from somewhere. Because there's just not that much carbon in that same kilogram. There's not that much carbon in that same kilogram.
See, my kilograms of, no, I have kilograms of carbon dioxide, that's what I want.
So your CO2 emissions would have to be way less,
They seem to be a lot less. A little more bang for your buck with the switchgrass.
but it's.
It appears.
You go down there and it's 0.029.
Yeah.
Well, that's kind of a big jump up, I would say.
No, 092,
Oh, yeah,
029.
okay, 30 and 100, yeah.
Yeah.
It's about a third.
It's a third. Okay.
That makes sense.
Okay, now, the coal is, so now we've got dollars, so coal, we go with coal. So we really, what we want is to go, CO2 per energy, and then we want to get, energy per dollars. No, we want to do it the other way.
Dollars per unit.
Yeah, if we do energy per CO2, and then we get dollars per energy, we will then end up with dollars per CO2, won't we? That's what we want. Okay, energy per CO2 we've got for coal is 0.092, 1 over, so 0.092 inverse 10.9.
What did you do?
Would you divide it by?
I just flipped that.
You did.
Yeah, I just flipped that. I've got energy per CO2, so 10.9.
10.9.
Yeah. Cool.
Megajoules.
So this would be megajoules per CO2?
Yeah.
Megajoules per CO2. 10.9. And switchgrass. See if I can squeeze it in here. 0.029 inverse. 34.5. 34.5 megajoules per CO2. Kilogram CO2.
Yeah. Okay.
Okay. Now let's look at the price. So the price of coal is $1,000 per megajoule.
Gigajoule.
$1 per megajoule, 1,000 per megajoule, right?
Okay.
$1
Brain just does things differently.
per gigajoule gives us 1,000 per megajoule. And switchgrass,
Wouldn't it be,
other way around. Thank you.
yeah, it'd be 0.01.
Thank you very much.
Okay.
0, yeah, thanks. We all make that mistake, don't we? We all make it. 001, thank you. Megajoule.
Okay.
That's why it's good to say it outside. What'd you call it? Group learning?
Partnership.
Partnership learning. There we go. Thank you.
Synergy.
Switchgrass
You should Google that sometime.
is 0.00025 per megajoule.
No.
Did I get that
Three
right?
O's.
Oh,
No?
2, 3, no.
It's more expensive. Oh, it's more expensive. No, it's more expensive. I do.
Too many O's.
Too many O's, too many Cheerios in the bowl. Got a little too happy with the O's.
Boy, when you change it down to these dollar prices, you're like,
He's just eating it for paying attention, that's what it is.
No, just going too fast. So many ways to make an error. Okay, so there we go. That many dollars per switchgrass. Okay, now we have to do dollars per CO2. Yes, we've got, this is energy, so we go coal.
10.9.
We're going to go 10.9 megajoules per
One CO2.
kilogram CO2. Hello? Oh, hey, Lizzie. I heard it. Can I call you right back? Let's do it. I'll be not answering, but certainly listening. Thanks.
Your price is slightly off the ground.
Yes.
You know why? It's because I got my banker calling me. Sorry. This is bad. This is bad. Worlds are colliding. Okay, so there's coal. Okay, so now we're going to get dollars per CO2, right? So that's going to, so we're just going to move the decimal over 3 places. What are you getting there, Ms. Munns?
0.0109.
Switchgrass is,
34.5.
thank you. $0.025 per megajoule. 34.5 times 0.0025. 0.8625. 0.8625. Gosh, that seems like a big difference.
1 kilogram of CO2.
That's a huge difference.
Seems too big, doesn't it?
So if you subtracted the Coles number from that, you would say the difference?
Let me think about this for a little bit. All right, let's knock this thing out. Okay, so here's what we did. Here's what we did. This was a team effort. Way to go, teams. High fives are coming here in a second. Yeah, okay, so what we did, we didn't make any mistakes. We just couldn't quite push through to the end, and then we did. All right, so we started off and said we're going to burn old carbon, coal, oil, gas. It's sitting here in a big pile underground. Or new carbon. Here's your photosynthesis. Here's your, this is basically your $2.50 per ton to get it to the biomass plant. This was going to be your $1 per ton to, or sorry, $1 per gigajoule, 1 per unit energy to get it. Here's the new economy. Here's the old economy. But gosh, it costs more to get the biomass there than it did the coal. So, we go back in here, coal's cheaper, biomass is more expensive, 2.5 times more expensive. Coal also has more energy density versus switchgrass. It also has a lot more carbon density than the switchgrass. And what we're taxing in this case is CO2, not carbon, so we did the molecular conversion as well. All right, then we decided we wanted carbon per unit energy. We got that for coal, 0.025 kilograms of carbon per megajoule. For switchgrass, it was significantly less. So the switchgrass was it was 2/3 as energy dense, but way lighter on the carbon, 15 to 70, 3 to 1, 5 to 1, almost 5 to 1, 15 times 5, 75, almost 5 to 1. Okay, so that led to some surprising results. We ended up with this many, if we actually multiplied that by 1,000, we'd have 92 tons of CO2 per gigajoule.
Megajoule.
Yeah, but
Oh,
it's,
yeah, when we
Yeah, so we can get, right.
Yeah.
Or actually, I think it'd be 92 kilograms per megajoule. Anyway, it'll pan out when we look at the Excel. And so the big breakthrough though, so we're looking at the, let's just skip ahead. The big breakthrough though was when we realized that 1 gigajoule of coal costs us $1. So we're paying $1 for it. And we're going to emit 72 metric tons of CO2. The switchgrass, on the other hand, we're going to pay $2.50, more expensive, but we're only going to emit 10 metric tons. And we'll say, well, is this free? Well, no, we are going to tax ourselves, but at the same rate, the same carbon tax. Now, the question is, what's the price? Well, the difference in emissions for that same gigajoule, remember, we're going to burn a gigajoule, the difference was 72 minus 10 metric tons of CO2 per gigajoule burned. The difference in price was $2.50 minus $1.50 per gigajoule of energy. So if we look at the difference, we paid $1.50 more, but we also emitted 62 megatons more, and we came up with about 2 cents. About 2 cents. So if we go back to our spreadsheet, per ton, yeah, thanks. Sorry, let's get a little crowded in there. All right. So, not that one. This one. This one. This one. Sorry, my colors aren't as pretty there. Yeah, the colors are good. Make this a little bit bigger so we can all see it. Maybe. Okay. Start at the top. So 28 megajoules per kilogram of coal, only 19 for switchgrass, and then I just inverted those and came up with kilograms per megajoule coal versus kilograms per megajoule switchgrass. Let's invert that. The coal is cheaper, $1 versus $2.50. That's per gigajoule, and I just converted it to megajoules by dividing by 1,000 for each one. All right. And now here's kilograms of carbon per kilograms of fuel. These are also given. So this guy was given. Yeah, 70% and the 15% were also given. Now, and I did this twice. I got kilograms of carbon per megajoule. So I multiplied kilograms of carbon per kilogram of fuel by megajoules of energy per kilograms of fuel. So if I want to be complete here, I can say kilograms of fuel. All right. So for every megajoule I burn of coal, I crank out 19.6 kilograms. Do the same thing for switchgrass. For every megajoule I burn, I pump out only 2.5 kilograms of carbon. And if we do our stoichiometry, we know there are 44 grams or pounds or unit mass of CO2 per unit mass of carbon. You can do it pound moles, gram moles, whatever you want to do. 44 by 2 is 3.67. Now,
Doesn't matter what kind of carbon it is.
It doesn't matter what kind of carbon. There's carbon 13. Well, for carbon 13 to be a little different, wouldn't it now? Yeah. All carbon 12 is the same.
Carbon 12 we're okay with.
You can put that in your pipe and smoke it.
That one we can.
Wouldn't recommend it, because then you're gonna get, carbon monoxide poisoning, and no, you don't want that. He says with a
I
cough.
want to smoke coal.
Hard to smoke coal. It's hard to set that stuff on fire. You know, pulverize it, dust it. Yeah. Okay. Now we want CO2 per megajoule. So I'm going to multiply. CO2 per carbon by carbon per megajoule. I'm going to get rid of carbon. And I'm just going to have megajoules when I'm done. So there we go for coal. There we go for switchgrass. I just ran it both ways. Oh, and then I converted it. Metric tons of CO2 per gigajoule is the same as kilograms per megajoule. Each one goes up by 1,000, and everything stays the same.
That made it nice.
Now, here's where I've managed to quiet the mind, get on back to the pencil paper.
See, I have 175 instead of 176.
Oh, really?
I'm like one number off of your whole problem.
Huh. Probably because you got that 15. I'll come look at it here in a second.
Well, if you look at your delta emissions,
62?
it's 61 instead of 62.
Yeah.
His is or mine is?
His is.
This is, so again, we went back to the coal. Inside this little box, we've got our 1 gigajoule we're going to burn. And again, we spent $1, but we made 72 metric tons of mess. Over here at the switchgrass, we spent $250, but we only made 10 metric tons of mess. And I wrote free out here because I wasn't really sure, am I going to pay for the CO2 or not? Well, I said that the difference in emissions on a gigajoule by gigajoule basis is 72 minus 10 is 62. The difference in price is $2.50 minus $1 per gigajoule. So again, we've got CO2 per gigajoule, dollars per gigajoule. So the price in dollars per metric ton of CO2 is $1.50 divided by 62 is 2 cents. Whew! So the change in cost I just got from the original input, $2.50 minus $1. The change in emissions.
How did they get 72 minus 10 to be 61?
Well, let me go out here a little
You
bit.
got some sig digs, cramping our
Well,
stuff.
see, even his sig digs for switchgrass got 10, mine's 10.3, not 10.45.
Yeah. No, it's all going somewhere.
I'll take a look, Shauna. I think it's because
It's gotta be 'cause I
are you using a
got
Macintosh?
No, I don't use Macintosh.
Okay, good.
I'm a Dell,
Okay.
Intel,
Okay.
no.
Sometimes those Macs get a little funny with the math.
Yeah, I'm trying to pick up Swift and I'm like, this is silly.
What's Swift?
It's an iOS coding language.
Okay.
That nobody likes except for him.
I hate Apple products. It's a
Well,
thing.
I struggled with the Apple this morning too. I had to clean the cache on Safari. I mean, it was.
See, why is
figured
your
it-
Delta emission 61 and mine is 62?
Because it's 72.9 and it's 10.5.
And if I do that, mine still stays 61,
Mine's 61 now.
or 62. Telling you.
Well, there's my cost. And then to wrap it up, we've got dollars, delta cost, and this is in dollars per gigajoule. Delta emissions, and this is metric tons CO2 per gigajoule.
Shauna, what did you get for your carbon tax?
My carbon tax, I got 2 cents.
Oh,
have the same answer. I'm just literally one number off and everything else throughout this whole problem.
So what we're going to do here is multiply, and this was thanks to Matt Byrne. High five.
Take that one.
All right. Back here, we've got, this is, this we got to put in, let's get the units right. This is,
Dollars per megaton?
yeah, dollars per metric ton CO2. There we go, 2 cents. 2 measly cents per gigajoule.
Seems, I could sell that.
Measly.
Right? Oh, I can stop that.
Measly. Now, the Matt Burns math here said, now we're going to look at the total cost of carbon. We're going to multiply that 2 cents per CO2 times our CO2 per gigajoule, and to burn that gigajoule, it's going to cost you another $1.76. That's where it comes in. The tax is going to come in. The tax man
Thought you were cool for being all energy dense.
is going to come in
Yeah.
at $1.76. Cha-ching. Well, sorry, Switchgrass man, you might be so fancy, so clean. You're going to have to pay too. Yeah, well, you are. You're going to have to pay too, but you're not going to have to pay as much, because to get that gigajoule, you only emitted the 10.45. So there's your quarter. You're going to have to pay 26 cents on that guy. Tax.
So in order to
0.2.
increase liability, you have to add more than 2 cents tax.
Yeah, this is your break-even analysis. This is your break-even. And, and so here's where the climate change deniers come in, the drill baby drill, the global warming, I don't believe in science, et cetera, is, well, yeah, who's gonna pay for everybody to move from Florida?
Man, that would be a great spreadsheet. Cost of like de-housing.
What's Bangladesh worth? That's kind of what it comes down to. That's what it comes down to.
This whole global warming thing,
That's what it comes down to.
No more turtle soup.
Darn it.
Yeah.
No more pickled frog's feet?
But that's the level cost. So you add these two together, and this total cost is at the $1 plus the 176 is your 276.
And really, we should have probably been paying these incurred, it's like a resource tax, carbon we've been emitting.
Mm-hmm.
It's displacing environmental something.
Well,
Do they call it environmental tax or something like that?
you can call it environmental tax, yeah.
Lisa Swallow's class had a term for it. I can't believe it.
Yeah. Well, there it is. That's a good analysis. We did the whole thing, start to finish, and figured out. And now, here's one more big picture thing for you. There's one more big picture, and this is to put the energy technology program into perspective, right? So you've got your science over here. This is your Steve Running. This is your Al Gore. Who's that other kid that's running around? Leonardo DiCaprio. Whatever, Matt Damon, Robert Redford, Sierra Club. Well, no, they're somewhere else. No, they're the actors. Never mind. These are the scientists. Let's leave those guys out of the science box. Just Steve Running and Al Gore. Well, Al Gore, you're not in there either. And
Is that you, Jalen?
Neil deGrasse Tyson was an astrophysicist, so he's not really.
Neil deGrasse Tyson.
is he?
hello.
How did you get in there?
This is what I want to show right now, is that we've got our scientists over here, So here's Steve running. Here, there's like the Mauna Loa oxygen, so this is where they measure the oxygen. There's also Keeling. This is the
Water and stuff.
Keeling Curve. So when I was with my daughter in San Diego, I came back from the men's room, I sat down, they said, what's this curve? Describe. I didn't know it was the Keeling, but climate change is what it is. It's the Keeling Curve that goes like this. It's the ratcheting of the CO2. It's the, hello, come on. Right, every year, CO2 goes up, here's your 400 ppm. Okay, now, so the scientists say, whoa, hey, look out. Now, the policy, so here's your Al Gore, here's your Donald Trump, say what you will. So the scientists tell them, they go, oh, really? I don't know, maybe we should do something about it. Okay, so bring in, here's Elon Musk. Bring in, I don't know, who's another super killer, Richard Branson, maybe, not really, Bill Gates, there you go. Bill Gates, there's the big BG, IBM, some of these other companies are like trying, hey, let's do this with the curve. Let's ratchet it down. This is also your Keegan Eisenstadt, your carbon traders, right? So,
What are we going to do with all this?
yeah, but we've got to get paid somehow, right? So, these guys get paid something to do their research, these guys get paid something to do this research, these guys make sure the bank keeps running. Kind of do, I mean, that's kind of what you better. Just make sure the bank keeps running, just keep that bank running, because if the bank collapses, like bad things happen if the bank collapses, they really, really do.
Watch
Sorry.
that movie, The Big Short.
Big Short's good.
Good movie.
Big Short's good. I watched it. So, but you could also, while we're talking about The Big Short, you could also have like the, you could have the technical trader. And the technical trader sits here kind of watching the bank. They also kind of watch insurance. And I can't remember the guy's name, sorry, but the medical doctor sitting in his bare feet playing the drums who lost his eyeball invented a financial mechanism basically to put himself between the bank and the insurance company so that he won. I mean, sorry, everybody else lost. Well, everybody in this picture.
Can I go ahead and short this?
Homeowner.
You guys are going to fail it a little bit.
Homeowner, whatever, guy with job, car, etc., property owner. Now, here's the tech, and we can put the engineers in here too.
Oh, man, don't put us in there.
Engineers are in here too. So the engineers have to come up with a technology basically to make this thing happen, and the policy people also have to say, hey, here is some, let's just.
Tech guys are allowed to do this.
Maybe here's a farmer. Maybe here is a tropical rainforest owner. Somebody who has the ability to sequester carbon in their crops. So the farmer could actually be paid by the bank to grow trees instead of crops. He really, really could. Like, hey, grow some switchgrass. Here's your carbon credits. Tropical rainforest guy would be like, hey, open a little cabana, bring some tourism down to see the rainforest, to see the snakes, to see the spiders, to see the gorilla, to see the animals, and here's some more money. Go send your kids to school, dentist, whatever, get grandma an apartment, something.
Water filter.
Just don't cut down just don't cut down the rainforest. Yeah, buy a water filter, don't cut down the rainforest. And so I think the next step, and this is where, well, you also need the actors, who's this guy? Leonardo DiCaprio, your Matt Damons, your whatever, the guys out there stomping media to also raise awareness. Well, they're rich too. They should pay the, hey, Gary, they should pay the technologists also, or the farmers, whoever, to bend this Keeling curve back down. The nice thing is, the reason the insurance companies should like it is they don't have to like pay for Florida when it goes under. So that's the big carbon world as we see it.
More on board.
Because the insurance company, otherwise, he's gonna have to go and pay the homeowner and buy his junky house just as it's dying, right? Cool. Okay, so we did science, we did policy, we did technology and engineering, talked about the bank, talked about, actors, influential people, media, talked about the insurance company, we talked about the homeowner, and there it is. That's the world. I mean, we could draw it a little cooler and simpler, but that's back of the envelope, back of the napkin view. All right, that's all I got for bioenergy. That's a wrap.